So far, we've seen that the deformation gradient can be decomposed into a rotation and a stretch. And we saw that the eigenvalues of the stretch are positive, and we can think of the action of the stretch as taking a circle, changing it into an ellipse, while preserving the directions of two special lines called the eigenvectors. Now, these two special lines almost look like truss members. So what can we define as strain? For each of these special lines, we can define strain using the log function, just like we defined for the truss member. So this motivates the definition of strain in two dimensions as the matrix logarithm of the stretch matrix U. Notice that in doing so, we have taken the deformation gradient and separated out the rotation part by doing the polar decomposition. And all we're taking is the stretch part and doing the matrix logarithm of it. Again, we're using the matrix logarithm function. Notice that it's not the log function in MATLAB, but it's the log m function, the matrix logarithm. This actually involves the eigenvalues of the matrix U. You see that the matrix logarithm can also be calculated using the log function and the eigenvalues like this. And this all makes sense because each eigenvector is like a truss member. So just like we define strain approximations, epsilon BO, here epsilon BO would be simply U minus the 2x2 identity matrix. And again, completely analogous to the truss member, the green Lagrange strain will be 1/2 of U squared minus the 2x2 identity matrix. Now, we see here that a nice thing about the green Lagrange strain is that it can be calculated without actually doing the polar decomposition. So here we've defined epsilon GL as 1/2 of U squared minus I, whereas here we're computing it as epsilon GL equals 1/2 F transposed F minus the identity. And in this way of calculating it, we're not actually doing the polar decomposition, which is a computational advantage. This is one of the reasons why the green Lagrange strain is a preferred strain measure in 2 and 3 dimensions. And here is a demonstration of why this formula and this formula give the same answer.